So let's look at a car going around in a circle, and it's going to go around in a circular path, maybe on a roundabout or something like that. And let's look to see what happens with circular forces, which allows the car to actually go in a circular path. So we've got an 1,800 kilogram car going around a circular path with a radius of 8.5 meters, and the maximum speed that the car can go is 85 kilometers an hour before it might start skidding or slide off the road. And we'll assume it's a nice level road, it's not angled or anything like that. And what we're going to do is we're going to find out what is the coefficient of friction between the tires and the road, which allows the car to go in a circular path. Because in a circumstance like this, the actual centripetal force actually comes from the force of friction. Because without friction, of course, the car would then just go in a straight line and go off the road. It would just go nice and perfectly straight. It wouldn't be allowed to go in a circular pattern like it is. So let's see what kind of measurements we can find. Now, first we can find out our FC. We've got a speed, we've got the mass, we've got the radius. So calculating FC is actually pretty simple. Now, first things first, I'm going to need to convert my speed from kilometers per hour to meters per second, and that would be approximately 23.6 meters per second. Once I have that, it's really easy for me to calculate my centripetal force, which is mv squared over r. I've got my mass of 1,800, I've got my speed of 23.6, and I've got a radius of 8.5, and I can put those into my expression. And when I calculate that, I get an approximate centripetal force of 118,000 newtons needed to let the car go in a circular path. Now this, of course, as I mentioned before, this comes from friction. Without the friction, the car is just going to go in a straight line like when it would hit a patch of ice in the wintertime. So I can take that force and I can make that equal to my force of friction. Now, of course, to calculate friction is just the coefficient of friction times the normal force. Now, in this circumstance, our normal force would just be equal to the force of gravity from the car, because the car is just sitting on a flat surface. So if I rearrange this for coefficient of friction, the coefficient of friction, of course, is Ff divided by Fn. I've got my force of friction, which is 118,000 newtons. My normal force in this case would just be my force of gravity, which is equal to mg. Now, if I calculate my mg, I get a force of gravity of approximately 17,700 newtons, which I can then put into my expression, 17700, and divide the two out. Now, when I divide the two out, I've got the force of friction, 118,000 divided by the normal force or natural force, which is 17,700, and I'll get a coefficient of friction of approximately 6.7. And of course, there's no units with the coefficient of friction. It's force divided by force. The newtons cancel out.